We are given an objective function. Are you able to see the objective function? We need to maximize. Yeah, the objective function is to be maximized. It's here. We need to maximize using the graph. You know, the constraints are already given to us. I think we know the message. The message is to, when given constraints, we are on step number 2. It means the problem has already been formed for us. And of which, me, when I was teaching in the last class, I emphasized showing you how to prepare, how to formulate the problems actually from the statements. I think that was what we did the very first class. Yeah. So that one should not really be a challenge this time. Yes. How do we go about this? What will be our first step? We now straight focus our eyes on the concept. Yes. Go ahead.
Include the equations of x1 and x2.
3x1 plus 5x2 is equal to 15. And 5x1 plus 2x2 is equal to 10. Right. And we start solving them quickly. We are starting with the very first one. What is 3x? We want to start with x1, right? We'll put x2 0 equal to 15, right? This will become 0. Well, 3x1 equal to what? 15. Divide through. So the intercept for x1 is what? 5. We are good?
Yes.
So it's the 5, comma, what is the x2? Let's go ahead and solve x2. If we already have x1, I think it's very easy. Work with the x2, we set x1 equal to 0. So 3 times 0, you know, plus 5x2 equal to what? 15. This shall be 0. 5x2 is equal to, I hope that I'm not even faster now you are relating because it's tough. 5 into 15 is 3, yeah?
Yes.
What is your question?
No, I don't have any question.
All right. We go to the next one, and the next one is 5x.
I have a question here on 5x2. When we put when we find x1 to be 5, are we not supposed to substitute where is x1 we put 5, then 5 multiplied by 3 to be 15 instead of the 0 you said?
You are a very powerful mathematician. You are a powerful mathematician. However, what we are looking for is not really the value of x. We are looking for intercepts. The key word here is what? Intercept. Intercept. So intercepts, we just find them by putting zeros for other ones, right?
No, so when you're finding x1 is to put 0 in x2?
Yeah, that's what we have done. That's what we do. Because we are finding intercepts.
So when you want to find x1, we put 0 on x2 for us to find x1. Then when we are finding x2, we put 0 on x2.
That is.
Oh, okay.
So 5x1 is equal to 10. Prove by 5, divide through by 5. x1 is equal to 2, right?
5. To 2, yes.
Isn't it?
Yes.
What is our x2? Let's go and resolve the equation. Now we want x2. So have 5 times 0 plus 2x2 equal to 10. 2x2 equal to 10 divided through by 2 x2 is equal to 5, yeah?
Yes.
Now you can ask me questions. What are your questions?
No, Manyanga Gundala. I was asking like, if you want to find x1 is to put 0 by x2, if you want to find x2 is to put 0 by x1. That was my question.
Yes, boss. The key word is that we are looking for what? Intercepts. We're not really looking for values of x and whatever. We are looking for intercept. Intercept simply means if you draw a graph like this, what is the value here of this graph and what is the value at the end here? That's what intercept is. So we are looking for intercepts.
Okay.
I think we can easily intercept these because these are already x1 is equal to 0 and x2 is equal to 0. Those are easy stuff. Now, the scale, how large should be our scale? Obviously, it's dependent on these numbers. What is the highest value of x1 we have between the two? On, when you look at this one, it's 5, right?
Yes, 5.
Yeah, so which means our scale can go up to beyond 5. And for y, not less than 5. So we can set up our simple graph. It is always on the positive side. That's why you're hearing that the value of x1.
Why are you putting y less than 5? Oh, the 5 is the negative 5. It's 5, beyond 5 also.
5, beyond 5. x1 on the x-axis, x2 here. Now, it is always on this side of the xy. Remember the x or y plane is like this, right? We always just work with this side because we don't have negative numbers in your program. That's why this says the x1 and the x2 is what? Is positive. And we put a scale. I think going up to 5, you can even put a scale of 1, 1, right? Because, I mean, it's not very large. Unless you're dealing with bigger numbers, that's where you put a large scale. So 1, 2, 3, 4, 5, even 6. 1, 2, 3, 4, 5, even 6. Question done, right?
Yes.
We already done. So let's plot the first coordinates. What is our x1? x1 is 5.
5.
x2 is 3.
3.
So you draw the line. Right.
Yes.
And this is less. So this equation, that is less, which means the wanted region is what? Is down, right? Less or equal. So you shade the unwanted region here. That conversation. Yeah.
Yes, sir.
Let's go. And the next one, x2 is what? x1 is 2. Then it's 5. So it's cutting like this, Is this really hard? No, sir. And the equation is less or equal, which means the left side is this side now. Which one is less? No. This is the wanted region. The defined region is less, right? The wanted region is
how do you find the unwanted region? Like for the coordinate, for the first coordinate, 5,3. How did you shade the what is the upper side like?
Good question. So first of all, you draw a what? A line connecting the two coordinates, isn't it? It's 5, what? 5, or it was 5,3. So when you draw this line, we'll go back to the original, inequality. How is it defined? Where is the wanted? We are told that the wanted region is less, you understand? It's less than this one. The lesser side of this, less than if you, it's on the lesser side, short. The lesser side is going down like It's downside of this equation.
How
This
do
is
you know that they want the lesser side? Because here it's 3 plus 5 is less than or equal to 15.
That's what the inquiry say. Like the question says, the defined region is on the lesser side. You get, this is less, you know. You look at this symbol, it's less, which means the wanted region is on the lesser side of this line. Now, when you move down here, the values of X and Y, they are decreasing as you move going this side, isn't it? They are becoming negatives, right? If you reduce this line, you pull it downwards, the figures will become negative, which means that's the lesser side. Like you move it downwards. So the lesser side is the wanted region. You shade the unwanted region, which is the opposite, the greater side. This is the greater side. You understand? All right. Then when we have this other one, we draw the line as well first, before we know where to shade. Where is the wanted region? The wanted region is also on the lesser side. Left side is always less. Let's just pick it like going to the left is less. You get what I mean? Going to the right is less. So lesser side, we're coming to the left. So the left side of this line is what? Is the wanted region. So the unwanted region should be on the right side, right? You understand? You get it, eh? Hello? Okay, are you back?
Yes.
So I was saying, even this one, the wanted region is on the left. That's left side, left. So which means the right-hand side is the unwanted region. We shade it going to the right. Which means your wanted region is within R. You get what I mean, eh? Because there is a line here that says that the wanted region is on the greater side. There is this another line here. X1 is greater or equal to 0. Which means where is x1 equal to 0? It's along this x-axis, right? That's where x1 is equal to 0, isn't it?
Yes, sir.
Let me put it like this. Now, x1 since in this one, the values of x are vertical, right? They are vertical, these are going upwards. So it is here. This is where the value of x is equal to 0, right? Because here is -1, yeah. So now, where is the wanted region? Now they have told you that the wanted region is on the what?
On the left side. It's where?
Check the time. It's greater. Like this is great.
Do you know where I'm getting confused, sir? I'm getting confused on like the first equation. I'm saying 3x1 plus 5x2 is equal to or less than 15. So my question is that since our first coordinate is 5,3, why?
Oh, I see the confusion. Hold on. We are not really substituting these equations into this equation. No. The equation defining this line is the equation. This equation is defined by this line we have drawn. So count this whole line as the equation. It's an equation. Remember, this line has come from this equation, right? Yes. So it is the whole equation. The whole equation now is this line. So we are looking for the lesser side of this equation. That's the message, which is this line. So the line is no longer just a line, it's an equation. Okay? Now, x1 is greater or equal to 0, right? Now it is greater. So we are looking for the values. The wanted region is on the greater side of where x1 is equal to 0, right? The greater side. Greater side of this line we have drawn, this one which passes on 0. You've seen it, eh? Where is the greater side? It's on the right hand side, isn't it?
Yes.
So, which means the unwanted region is on this other side, right?
Yes.
The unwanted. And then the other one is the x2 is greater or equal to 0. Where is the x2 equal to 0? X2 here is 6, here is 5, here is 2, here is 1, here is 0. So it's along the x-axis. You've seen that. It is along the x-axis. Now, where is the wanted region? It's on the greater side. You get what I mean? The
Which
values
side
of
the
greater one, where are the values of x2 increasing? It's on top, right? As you go on top, the values of x2 are increasing, right? As you go down, the values of x are decreasing towards negative. You get what I mean, eh?
Yes, sir.
So the unwanted region is this one. You shade this one down part, which means this arrow is the wanted region. You got it?
I get it.
All right. And now, having communicated this to us, then it becomes very easy, right? I believe in just making sure that one example is clear. Yeah, it's not about rushing to have many examples. So we can even take the whole time, but just on one example, as long as you understand it, you can do the others. Okay. Now, remember what I said last time. We need to maximize this function. We need to choose the coordinates now from this defined region. You pick what? The vertices, right?
Yes, the corners.
The corners. So pick the coordinates. What are the coordinates here where 2 is here on 2? These 2. What are the coordinates?
2,2.
Check this corner here where I put a dot. What is the value of x1?
This corner.
Yeah. x1 is
the value of x1 is 2.
Yes, it's 2. Comma what is the value of x2?
It's 2,2.
The values of x1 are x2 are these, like this. These are values of x2. Then these which are
Sizaenda so straight, and then zaina pali kona number 2, then tizakonika so.
Hold on, we are on 2 here, x2. Then we just move to the left like this. What is the value?
Okay, so it's 2,
what's the value
0.
Yes, it's 2,0. Along the axis, really, we just have 0 for the corresponding part. Okay. So the other vertex is this one. What's the value of x there?
The value of x is 1. 1,2.
1,
1. And then we choose another corner thing. Is it 1, 1,2?
Yeah.
1,2.
Can you go like this?
And the other one is 0,3.
0. Percent. And then when we get there now, life becomes easy. We are maximizing the function. Which one maximizes the function? Your function is which one?
Our function is z equals to 5x1 plus 3x2.
So what is our x1? First coordinate
x1 is
2 plus
the
3 times 0, which is 0. This will be 10, right? So the profit will be 10. Let's go to the next one.
The next one to be 5 multiplied by 1 plus 3 multiplied by 3. This should give us
By 2.
4
3
by
by
2.
2.
So 6 plus 5, 11.
11.
Then the
Okay.
other one will be 5 multiplied by 0. 5 multiplied by 0 plus 3 multiplied by 3. So the next one will be 6, 9.
Now 3 times 3 is 9.
Yes,
It's
9.
not same as 3 plus.
So we choose
The maximum.
the maximum.
So when you are minimizing, I think I should just communicate in advance. When you are minimizing, choose the smallest. So if you were minimizing, you could have chosen this one.
9. As we are maximizing, so we are choosing coordinate 2, which is giving us 11.
So how many units of X1 should the person produce to maximize the profit?
Use of X1 is 1, then X2, 2.
Yeah. And then the maximum profit shall be 11 units.
11 units.
Is this really hard? No, sir.
It's not hard when I'm solving it with you.
No, the thing is that you haven't just practiced. You have not practiced yet. If you with math, it's about practicing. Basically, that's that. Yeah. Otherwise, if you have not practiced, you can keep on talking to the teacher even every after 5 minutes. Plus, you just say, this teacher I'm speaking, he's speaking, I'm not understanding. It's not clear. I need to hire another one. But it's not really that. Yeah, key in math is practicing. Like, have time to practice. If you can have time to practice, everyday practice, you will understand that actually the teacher is very clear. It's clearer, actually. Okay. Any questions?
No questions, sir.
Anyways, let's do another, probably the last example now. Minimize. You already know the story. Get the get the coordinates, set them equal to 0. So x1, the constant, x1 plus 2x2 is equal to 40. 3x1 plus x2 is equal to 30. Now we have 3 constraints, right? X1 plus 3x2 is equal to 60. These we don't really care about them because we mean that we are just on the right side, on the positive side. That's what that means. Let's start with the first one. What's the value of x1?
Yeah.
Yes, x1 is 40, yeah? Because it will be x1 plus the 2 times 0, yeah? Equal to 40. The other one will be 0. Get what I mean? So x1 will be 40. Get it, right?
Yes, sir.
Then 0 plus 2x2 is equal to 40. So that x2 can be equal to what?
1.
What do you mean by 1?
X1 is 40, right? So when we substitute study x1 to take up of 40.
We are not substituting, we said we are looking for intercepts. Babos, Malema.
I know about I'm confused.
Okay.
So x1 is anchor 40, also 40. Then x2, 0 multiplied by x2 will be 20.
Yeah. X2 shall be 20. You divide this into, huh?
Yeah.
Babos. Even in secondary, this is what you were doing. It's only that you have mixed up the concepts. You have mixed up. I understand. When you're solving the functions, yes, you substitute because you're looking for the values of x. You get what I mean? But in linear programming, where we are trying to graph, we look for intercepts. We don't substitute. Okay? Times 0 equals to 30. So you divide through by 3 so that x1 is equal to what? 10, right? What will be the value of x2? 30, right?
X2, yes, 30.
X1, the last equation, 4x1 plus 3 times 0 equal to 60. It will be 15, yeah? X1 is 15, isn't it?
Yes.
Mm.
X1
And so that
X2.
Then X2 what?
X2 be X2 be 20.
Simple. So now we look at the scales that we have to use. Obvious. Let's look at the scales. We are minimizing the function though. Yeah, let's look at the scales that we need to use. For x, what's the maximum value of x we get? It's 40, right? 40. Then for y, what's the maximum we can go? 30. So maybe we can try to use the scale of 5 and see what really happens. Let's see how the scale of 5 can do with us. So 0, 5, 10, 15, 20, 25, 30, 35, 40. Okay, let me just remove this coordinate here, the second one. Before I erase it, x1 is 10, right? It was 10, comma 30. Okay. I want us so that we can put the scale a bit down. It can be like this so that it fits. Okay? 0, 5, 10, 15, 20, 25, 30, 35, and 40. Right? And then you start 5, 10, 15, 20, 25, 30, 35. Yeah? X2 and X1. Question. Let's start graphing them. One. The first one. Is 40, what?
40, 20.
Like this. Where is the wanted region? Less or greater?
Less.
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 So we shade the unwanted region like that. Dun, dun, dun. Vivo type? No. The next equation is this one. That's the next graph. 10. X1 is 10, comma what? Comma 30. Like that. Where is the wanted region?
The wanted region is
it's greater now. You see it, right?
It's greater.
It's here.
Oh,
it's here. So which means now the wanted region is on the right-hand side. So the unwanted region is what? Is this side on the left. See what I mean? Then the next one.
Next one is 15,
X
20.
is 15,
20.
Is going. Where is the wanted region?
Greater.
Greater. It's on the greater side.
So we should
which means the unwanted, exactly this side. So which one is our wanted region? Region R. Where the vertices here, right? Also here, also here, and here. Right.
Five children have a party 10 party corner.
No, corner. We are following region R. Region R.
Oh, okay.
Let's pick the first coordinates on point to this one. 40, where there is 40. What is the value of x1?
40,15.
40, what? What's the value of x2 on 40, along 40?
X2. Moving about now, 110.
When you are standing on 40 here, this is the value of x1. What's the value of y or of x2?
X2 is it not 15?
How?
I'm confused, sir. Are we supposed to move along the?
Yes, you're moving along the same point, no diversion, like in a straight line. When you stand here, vertically, this is 40, move to the left. This is 0. The value of x2 is 0. You understand?
Na advantage region fikako. I thought maybe sister considering doing up.
We are picking the values, like we're picking the coordinates, you know. These are coordinates. It's x, x1, x2. That's all how we pick coordinates. We don't care whether it's an unwanted region or wanted region or what, but we are just looking for x1 and x2. That's
all. Okay.
Oh, okay. Okay, here on 15, what's the value of x? 1.
Value of x1 is 15. The value of x2 is 15,10.
Look, we are 15 is the value of x1. Then you move in the same line to the left. What is the value of x2? Like the value of x2, as I said, they are like this. This is how they are, you know? Yeah. So straight here, this is the value of x2 is 0. It's 0, 5, like this. You get what I mean? So this is 15,0. As long as you are along the... Sorry?
That's 15,0. Oh, okay.
Yeah, as long as you're on the axis, it's 0. All right. We go to the next. What do you think would be the value of x1 here? X1?
Next one.
Yeah, when you move downwards.
Next one. No, so side, no.
We are here. We are here. Well, on this one, this vertex. Stevens are so. What could be the value of x1?
Is it not 8.5 somewhere there or 9?
How come 9? Like you just draw a straight line coming down like this to the, down. That's where you pick the value of x1. Okay? So what do you think is that?
Okay. Can be 6, 5.5 somewhere there.
Yeah. Right. So could even put 6, I think. Yeah. 6. Then when you move to the left now, what could be the value of
14.
X? 14. Okay. What is your question?
Do you have any question?
You are sure?
Yes, sir.
Yeah. Okay. All right. So I think if you have picked the coordinates, it's fine. The graph is no longer needed very much now. If you pick the coordinates, because okay. Let's start the substituting. Start with the first one. So it's 20, 40 plus what? Plus 10 times 0, right? We are substituting into this one.
So the first one is 800.
Okay, 800. So write 800. We go to
the second one is 2 multiplied by 6.
Did we pick this coordinate here? This one? No.
Which one?
This one. This one should be 5, comma what? Here. This one. The last one.
17.
5, 17. Yeah. Okay. Then we go to the next one.
6, 14. So it will be 20 multiplied by 6 plus 10 multiplied by 14.
10 times 40. It's 140. Plus, 20 times 6 is 120, right?
Yes. And so be
260. Okay. This line draws here. We'll just pass it here, say 260 for the second ones. Okay. Let's go on to the next one.
The next one is 5, 0, which will be
20 times 15.
300 plus 10 multiplied by 0.
Which is 0.
That will be 300.
300. This is 300. Let's go on and pick this one.
5, 17 should be 5 multiplied by 20.
Which is 100.
Plus 17 multiplied by
10, 1 second.
270.
270. So, which one is the minimum or whatever? The minimum cost?
260.
260. So, what values should you provide to minimize the function? The optimal values. X1 is equal to 5. X2 is equal to what? 17. See,
Not
mommy.
to 14. Near 14 side per side.
Oh,
Oh,
near
near
14.
so x1
Yeah,
should
yeah,
be
yeah, yeah.
6, then x2 should
Oh,
be
this is 270. Yeah, yeah, yeah. So this is 6 comma.
6.
Thank you. 6 comma 14. Mm. Any question?
No question.
All right. All right.